Hello everyone. Today's topic of discussion is data sufficiency, and in today's video we'll be discussing problems related to word problems. Okay, I have already made a couple of videos on basic algebra and exponents where we have discussed somewhere around like 15 to 20 data sufficiency questions from of 700 to 800 level, right, in GMAT. Now in today's topic we'll be discussing word problems, and again the difficulty level of the questions will be from 700 to 800, right? Alright, so without wasting your time any further, let's start with the questions. So we'll be following the same drill that you'll be pausing the video as soon as I show you the question on the screen. You'll pause the video, you'll try the question first by yourself, and then you'll play back the video in order to understand how to approach a particular question. Alright, so please pause the video and try this question. Okay, let's see what this has to say. 10 years ago, scientists predict that the animal Z would become extinct in T years. So 10 years ago, the scientists they predicted that this animal Z, this would basically become extinct in 10 years. What is the value of T? So 10 years ago, they predicted that in T years, this animal Z would become extinct. Now there are two possible cases which I can think of. One is when, or effectively three possible cases. One is when the value of T is less than 10, right? So the animals had got extinct in the past itself. Another scenario will be when T will be equal to 10. In that case, this animal Z would become extinct in the year itself, the year that we are talking about, right? Or the year the author is, or when the author has written the statement. And third possibility is when T is greater than 10. In that case, we'll say that it is yet to extinct. These are the three possibilities that can happen if we talk about T in terms of 10. Okay, let's see what this statement says. Statement number 1. Animal Z became extinct 4 years ago. Now animal Z became extinct 4 years ago. So again it's going in past. So this is 4 years from, like 4 years going in the past. So if you're going 4 years in the past, can I say when scientists gave this statement, they gave this statement 10 years ago. So for example, let's suppose scientists gave their statement, let's suppose in 1980, and the author wrote this statement in 1990, right? That's why the author is saying 10 years ago scientists predicted that. Now the statement one says animal Z became extinct 4 years ago. So 4 years ago basically mean animal Z became extinct in 1986. So from 1980, when actually the scientists predicted that animal Z would become extinct in T years, so T years would simply be the difference between 1986 and 1980, which will effectively be 6 years. Which will effectively be 6 years. So do we have a conclusive answer from statement Z? Yes, we do have a conclusive answer from statement Z that the value of T is 6. So if we write D, A, B, C, E, so either my answer is A or it will be D if B alone is also sufficient, which means B, C and D are out. Now second statement is, if the scientists had extended their extinction prediction for animal Z by 3 years, their prediction would have been incorrect by 2 years. So if they had extended their prediction for animal Z by 3 years, their prediction would have been incorrect for 2 years. Now when it says that they had extended their prediction by 3 years. That means their prediction is t plus 3. Now, first of all, we do not know the value of t. So what, like in how many years this animal Z would become extinct, or according to the prediction of scientists, this animal would become extinct, we still do not know that, because we do not know the value of t. Now moving on, it also says that their prediction would have been incorrect by 2 years. That's a very good statement, that it would be incorrect by 2 years. Now this has two interpretations. One is, there's a possibility that the animal Z got extinct in t plus 3 minus 2 years, which is t plus 1 years. Another possibility is they got extinct in t plus 3 plus 2 years. This will be t plus 5 years. So both the ways it's possible, because it says incorrect by 2 years. So incorrect by 2 can mean both the ways. So even if you knew the value of t, now in this case we do not know the value of t just by using statement 2. But even if we knew the value of t just by using the second statement, we still would not have figured out the actual value, because incorrect by 2 will have both the interpretations. So D goes out and our answer simply becomes option number A. Okay. Alright, let's move on. Pause the video and try this question, please. Alright, let's see what we can do with this one. So Bobby and his younger brother Johnny have the same birthday. Johnny's age now is same as Bobby's age when Johnny was half as old as Bobby is now. Okay, now this is an age-based problem. Let me just give you like a couple of insights as far as age-based problems are concerned. Whenever you have an age-based problem, try to form a matrix, something like this. So you will write the name. So we have Bobby, we have Johnny. And we'll make three signs. One is positive, one is 0, and another is negative. Positive stands for future, 0 stands for present, and negative stands for past. So positive stands for the future age, 0 stands for the present age, and negative stands for the past age. Now depending upon whatever information is given to us, we'll plug in the information in the matrix and then we'll solve it further. So Bobby and his younger brother Johnny have the same birthday. Johnny's age now basically means it's the present age, is same as Bobby's age when Johnny was half as old as Bobby is now. So let's read this statement again. Johnny's age now, let's say the present age of Johnny is X. Let's try to fill in the matrix as much as we can. Johnny's age now, which we have considered to be X, is same as Bobby's age. When Johnny was half as old as Bobby is now. So let me solve this part first, that Johnny was half as old as Bobby is now. So if I consider Bobby's present age to be Y, so somewhere in the past, Johnny will be half of Y. When Johnny was half as old as Bobby is now. So whatever the present age of Bobby is, in the past, at some point of time, Johnny's age will be half of Y. At that point of time, still not over, at that point of time, Bobby's age should be equal to Johnny's current age. This is what the statement is. Johnny's age now, X, is same as Bobby's age. So X and X both are X. When? When Johnny was half as old as Bobby is now. Okay. What is Bobby's age now? Now remember one more thing. This is basically present, and this is okay. I have done one thing wrong. I just, instead of plus, I should have used a minus here because we were talking about the past age. So, but I guess the concept is clear, right? I just made a mistake with the sign. I have put in the values, instead of in front of negative, I have put the values in front of positive. Okay, so please don't mind that mistake, but the concept remains the same. Okay, so Johnny's age now, which is X, is same as Bobby's age when. So that means you are again going to the past. So X and X, when Johnny was half as old as Bobby is now. So if Bobby's age now is Y, then at that point of time Johnny's age will be half of Y. Now remember one thing, the number of years by which Bobby's age has increased will be equal to number of years by which Johnny's age would have increased, right? That's how the comparison is being done. Which means without even going through statement 1 and 2, you should be able to say that y minus x should be equal to x minus half of y, or you will say 2x is equal to 3y by 2, or x is equal to 3y by 4, or you can say x will be equal to 0.75. Now what's the question? What is Bobby's age now? So Bobby's age now is y. We need to figure out the value of y. So if I can get x or y somehow, or the difference between them, or the relationship between them, anything between them will basically help me in getting my answer. First statement is Bobby is currently 4 times as old as he was when Johnny was born. Now, if we talk about when Johnny was born, first of all, I'm going to remove this plus sign because future is not required. Now, when Johnny was born, now Johnny's current age is X. So Johnny's age when he was born would definitely be 0. So we are again going in the past. Let me write past here, which means we are basically again going X years back. If I go X years back for Bobby also, then Bobby's age will become Y minus X. Then Bobby's age will become Y minus X. So Bobby is currently 4 times as old as he was when Johnny was born. So Bobby's current age is Y, and this is 4 times the age of Bobby when Johnny was born. So Y is 4y minus 4x. So from here we should get 3y is equal to 4x. This is exactly the information that we already have. This is exactly the information that we already have. So does it give us any other piece of information? No, I don't think so. So is statement 1 alone sufficient to answer the question? No, it is not. Which means A goes, D goes. If A alone is not sufficient, then both alone will also not be sufficient. Second statement, Bobby was 6 years old when Johnny was born. So Bobby was 6 years old when Johnny was born. So X years back, the age of Bobby was 6. So we can say, if I use statement 2, okay, where should I write? I'll write statement 2 conclusion here itself. Bobby was 6 years old, so we can say that y minus x is equal to 6. Now if y minus x is equal to 6, now we already have x is 0.75y. So when I'll replace x by 0.75y, I'll get y minus 0.75y is equal to 6. Now can I get a conclusive value of y from here? Yes, I will. That is exactly what we're looking for. So do we have a conclusive answer just by using statement 2 alone? Yes, we do have. Hence our answer is simply B. So in this age-based problem, whenever you solve, always try to write the names at the top and then always write plus minus 0. Plus should represent what's happening in the future. 0 should represent whatever is happening in the current situation or in the present situation. And negative should always talk you about the past situation. Then simply plug in the values, try to understand what the statement is saying. And always remember, like for whatever number of years the age of one person increases or decreases, that difference will also be the same for the second person also, right? So that difference will not be changed. So that always helps you, that will always give you one equation at least. All right, pause the video and try this question, please. All right, let's see what we can do with this one. They are X high level officials where X is a positive integer. Each high level official supervises X square mid level officials, each of whom in turn supervises X cube low level officials. How many high level officials are there? Basically we need to find out the value of X. Now before we move on to what we have to do and to the statements 1 and 2, let me make you understand this statement. Let's say hypothetically the value of X is 3, for example. That means there are 3 high officials, 1, 1 and 1. So first high official, second high official, third high official. Now each of these high official will supervise X square mid officials, which means each of them will supervise 9 officials. So 1, 2, 3, 4 and like this 9 officials. Similarly 1, 2, 3, 4 and 9 officials. 1, 2, 3, 4 and 9 officials like this. So each of whom will supervise 9 officials. And each of whom in turn will supervise X cube, which is 27 officials. So each of these 9 people will have 27, 27, 27 and so on and so forth, 9 times. Again this will be 27, 27 for third one, 27 and again 9 times and so on and so forth. This is basically what it means. Okay, there are X high level officials. Each high level official supervise X square mid level officials, each of whom in turn supervise X cube low level officials. Right, now let's see what can we do, because this is just to make you understand. Now let's see what information is given to us. Okay, there are fewer than 60 low level officials. There are fewer than 60 low level officials. Okay, so let's start with X is equal to 1, because it says that X is a positive integer, so the minimum value of a positive integer is 1, which means there will be a 1 high official, there will be 1 mid level official and there will be 1 super what do you call this, low level official. This is one possibility, no denying on that part. Second thing that we can do is we can take X is equal to 2, so you have 1 and 1, so we have 2 what you call this, high level officials. Now each of them will have 4 mid level officials. 1, 2, 3, 4. 1, 2, 3, 4. So this is high level, and then we have this what you call this, mid level. Now each of whom in turn supervises X cube low officials. X cube is 2 cube, which is 8. So this guy will have 8 under him, this guy will have 8 under him, this guy will also have 8 under him, this guy will also have 8 under him. 8, 8, 8, 8. Now let's add how many do we have 60, or do we need to move further? So there are fewer than 60 low level officials. So 8, 8, 8, 8. So this will give you 32. and this is 8 8 8 8, so this will again give us 32, so which will basically give us 64. So I don't think there's any point of going further, because if 2 itself is giving us like 64 low level officials, I don't think we should move forward. So the only possibility that we have is this one. There is one high level official, then there is one mid level official, and then there is one low level official. I think this question would have been much more interesting if instead of 60 they would have given the number 65, and in that case there would be two cases, right? And then the question would have been much more interesting. Anyways, so from statement 1 we do have a conclusion, which means B goes out, C goes out, and E goes out. Statement 2 says no official is supervised by more than one person, so which basically means there is only one possibility, which is 1. So again we will have 1 1 and 1. So this will definitely give us the answer, hence our answer is D. That's it. This was pretty simple once you understand what the question basically means, right? But I believe question should have been a different, like instead of 60 they should have given 65 or something else. Alright, let's move on anyways. The next one. Pause the video and try this one. Okay, so the question says in the game Kako, a player is awarded 1 tick for every third alp captured. Okay, we have 1 tick for every third alp captured, and 1 click for every fourth book captured. Okay, you get a tick for every third alp that you capture, you get a click for every fourth book that you capture. The total score is equal to product of clicks and ticks. Okay, so our score is basically ticks and clicks. Okay, if a player has score of 77, how many alps did he capture? Okay, so one thing is for sure, that the number of ticks and the number of clicks that you'll be getting will be integer. Like you won't get 1.5 tick or for example 7.8 clicks. That's not possible, because for every third alp that you capture you get a tick, for every fourth book that you capture you get a click, which means you will have integer values for ticks and clicks. Now if the product of ticks and clicks, I'm going to take them to be A and B just for the sake of solving the question. So A into B will basically be equal to 77. So if A into B is 77, then what all possibilities do I have? I have 1 into 77. I have 77 into 1. I have 7 into 11, and I have 11 into 7. These are my 4 possibilities. Because A and B would be integer values. I can't have anything else. So what all case do we have? I can have, if I write ticks and if I write clicks. So 1 tick, 77 clicks, 77 ticks, 1 click, 7 ticks, 11 clicks, and 11 ticks and 7 clicks. These are the only 4 possibilities that we can have. The question is, how many alps did he capture? Now even if I don't move on to like statement 1 and 2, alps is basically concerned with the number of ticks, right? So if we get 1 tick, that means he would basically capture 3 alps. For the second one, it will be 77 into 3. So 70 into 3 is 210 plus 21, which is 241 alps. This will give us 21 alps, and this will basically give us 33 alps. These will be the number of alps captured. Even before moving to statements, this is what we should be able to conclude from the given information or the fact given to us in the question. Now let's see what the first statement says. The difference between alps captured. Okay, if I have written alps, let me write the bergs also first. So 77 into 4, so 70 into 4 is 280, 280 plus 28, so that is 308. This will give us 4, this will give us 44, and this will give us 28. Okay, so these are the possibilities for Berg also. If in case they have given any statement pertaining to Berg, then also we should know that. Now first statement, the difference between Alps captured and Berg's captured is 7. Like if I see the number 3 and 308 is definitely not 7, 241 and 4 definitely not 7, 21 and 44 definitely not 7, 33 and 28 difference is 5, which means I don't have anything. So none of the 4 options satisfy, or basically I can't eliminate the any 3 of the 4 statements also. So does statement 1 give me a correct answer? No, it doesn't, which means A goes out, D goes out. The number of Alps captured is divisible by 4. Now number of Alps captured is again not divisible by 4. Either you have 3 or 241 or 21 or 33, which means B alone is not sufficient. The difference between Alps captured and Berg's captured is 7. And the number of Alps captured is divisible by 4. Even if we combine these two, we still have nothing in common, because both these statements are not giving us any of the following options. Leave apart the common part, we don't have any conclusion for any one of them, which means combining both of them will still won't give us any answer, which means our correct answer is option number E. That is, combining both these statements, we are still not getting the correct answer, or we don't have a conclusive answer. Correct is not the word. We do not have a conclusive answer. The answer is E. That's it. Alright, let's try the next one, the last one as far as this video is concerned. Pause the video and try this question, please. Okay, let's see what we can do with this one. Chandra and Ken are waiting in line for concert tickets. Okay, if each person take up 2 feet of space in a line, how long is the line? Okay, so it's like there would be a window where the tickets are being sold, and then there would be people standing right in front of it, right? And every person takes up 2 feet of space. So it's like this is like 2, then this is again like 2, this is again like 2, it's again like 2, this is again like 2. This is basically what this statement is saying. So C and K are waiting in a line for a concert tickets. If each person takes up 2 feet of space in the line, how long is the line? Statement number 1, there are 3 people in front of Chandra and 3 people behind Ken. Now, if there are 3 people in front of Chandra, so we have 1, 2, 3, then we have Chandra, and 3 people are behind Ken. So we have, there would be Ken somewhere, we do not know where exactly is going to be, and that's 1, 2, 3. Now it may happen that Ken is like one of the possibilities that case number 1 will be we can have dash 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 C, then you have K, and then you have dash dash dash. Another possibility is you can have dash 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 C, probably 2 dashes, then K, and then 3 dashes. It may also happen that, but suppose K is somewhere here, and after K you have 1, 2, 3 people, and before C you have 1, 2, 3 people. There will be a lot of possibilities. There is like actually no end to it. So does statement 1 alone gives us the conclusion that we require? No, it doesn't. A goes out, D goes out. Statement 2, 2 people are standing between Chandra and Ken. There are 2 people standing between Chandra and Ken, which means you will have C double dash K. Now how many are before C? No idea. How many are after K? No idea. You can also have K then double dash C. How many before K? No idea. How many after C? Still no idea. Still no idea. If I combine both these statements, so what all common conclusions can I draw? Conclusion number one. If there are two people standing between C and K, so let us first draw C double dash K. There are two people standing between C and K. Or we can have K double dash C. If there are two people standing between C and K and there are three people in front of C, so we will have 1, 2, 3 and three people behind K, so 1, 2, 3. A possible case, a fairly possible case. Or, so this is like first possibility, or let's keep it as it is. So we have three people in front of C and we have three people behind K. Exactly this conclusion that we came up with. And at the same point of time, there are two people standing between C and K also. So both of them are a possibility. So do we have a final conclusive answer? No, we don't have a final conclusive answer. Which means C and C is also out, B was already out, which means our answer is simply option number E. Again, thinking of all the possibilities, that's the main concern, right? So I hope you have enjoyed these 5 questions. You would have learned definitely something new, right? Interesting questions again of the level 700 to 800. So that will be all as far as this video is concerned, guys. Thank you so much for watching the video. If you have any concerns, any questions, any queries, please feel free to ask them. You can WhatsApp me, you can mail me, or you can put that in the comment box also. And please do subscribe to our channel also for more videos and exam related content on GMAT, GRE and SAT. If you're looking for any further help regarding the exam preparation, you can always contact us. Alright guys, thank you so much. Keep watching and keep learning. Thank you so much.